1942, the Pacific Theater. Japanese infantry deployed a tactic that had never failed them. They called it the Banzai charge. Hundreds of soldiers screamed, fixed bayonets, and sprinted toward enemy lines. In earlier conflicts, this psychological shock broke the defenders. Men panicked and fled. But when they hit American positions, the result was a massacre. The charges were shredded, bodies piled up in the surf and the jungle floor. The Japanese commanders were baffled. Their shock troops should have been inside the American trenches within seconds. Instead, they were being cut down at a distance. What was the difference? The answer was a piece of wood and steel. The United States was the first nation in history to equip every single infantryman with a semi-automatic rifle. At first, the Japanese soldiers felt pure terror. They believed they were facing hidden machine gun nests at every turn. Then, they realized the truth. Every individual American soldier possessed the firepower of a small squad. This realization didn't lead to a retreat. It led to an escalation. Both sides began searching for ways to kill more efficiently. The fighting in the Pacific reached a level of horror previously unseen in modern warfare. Why did this change happen? The seeds were planted in 1918. The First World War had just ended. Military planners in Washington looked at the data from France and Belgium. The results were uncomfortable. Machine guns and heavy artillery had dominated the landscape. Meanwhile, the average foot soldier was still using a rifle from the previous century. The bolt-action rifle was the standard. To fire a single shot, the soldier had to manually lift a handle, pull it back, push it forward, and lock it down. This took time. It broke the soldier's aim. It was a slow process for a fast war. The Americans looked at their M1903 Springfield. It was accurate, it was reliable. But in a close-quarters jungle fight, it was a liability. The Army leadership demanded a breakthrough. They wanted a weapon that fired every time the trigger was pulled. No manual chambering, no heavy crews, no bulky tripods. They wanted a machine gun's power in a single man's hands. In 1919, the United States Army officially opened a competition for this new weapon. The concept itself wasn't a mystery. Private companies like Remington and Winchester had produced semi-automatic hunting rifles since the early 1900s. The civilian technology was already there. But there was a massive technical hurdle. The Army refused to change its ammunition. They insisted on the .30-06 Springfield cartridge. This was a high-pressure, long-range round. It was powerful enough to kill a horse at 1,000 yards. Fitting that much raw power into a self-loading handheld rifle was considered impossible by most engineers. The search for a solution would take nearly 2 decades. .30-06, that was the standard. The military had 3 main reasons for keeping it. The round remained lethal at extreme distances. It delivered massive kinetic energy on impact. Most importantly, the warehouses were overflowing with millions of rounds left over from the First World War. But the cartridge created a mechanical nightmare. It generated intense chamber pressure. The powder charge was massive. Any rifle firing it had to be strong enough to absorb that violence without disintegrating. Commercial semi-automatic rifles existed in 1920, but they were fragile. They used weak cartridges designed for civilian hunting. When engineers tried to build a semi-auto for full-power military rounds, the results were disastrous. The rifles became too heavy for a soldier to carry. The French tried first. During the war, they deployed the RSC 1917. They manufactured 86,000 units. The weapon was a failure. It was too long for the trenches and weighed nearly 11 pounds. The gas system was the weak point. Carbon buildup clogged the mechanism almost instantly. After 100 rounds, the rifle turned into a club. Soldiers hated the weapon. They eventually jammed the gas ports with metal to turn them back into manual bolt-action rifles. By the early 1920s, the experts agreed. A reliable semi-automatic rifle using full-power ammunition was an engineering impossibility. Then, John Garand arrived. He walked into the Springfield Armory in 1919. He ignored the conventional designs. His solution was a gas-operated system built specifically to survive the .30-06. The mechanics were precise. When the trigger was pulled, a portion of the hot propellant gases bled through a port. These gases entered a cylinder located under the barrel. The pressure slammed into a piston. The piston pushed an operating rod. The rod traveled backward, unlocked the bolt, and ejected the spent brass. On the return stroke, it stripped a fresh round from the clip. The system worked because it distributed the violent energy in a controlled cycle. No single part took the full brunt of the explosion. Garand solved the problem that had defeated the world's best gunsmiths. But a single decision almost changed everything. During the testing phase, the Army considered a new cartridge. They called it the .276 Peterson. Why change a proven round? It seemed logical at the time. The Peterson was smaller and produced less recoil. Garand even built a version of his rifle specifically for this lighter caliber. At first glance, the Peterson was the future. But in reality, the massive stockpiles of .30-06 were too valuable to throw away. The military chose the more powerful round. General Douglas MacArthur personally stepped in and ended the debate. He demanded the rifle use the existing ammunition. John Garand went back to the drawing board to finalize the heavy caliber design. The M1 Garand was born. 10 rounds. That was the original capacity of John Garand's design. It used a .276 caliber cartridge. But the Army Chief of Staff stepped in and killed the idea. The reason was simple. Stockpiles. The military already held millions of rounds of .30-06 ammunition. They refused to switch. Garand had to redesign the entire internal mechanism to fit the larger, more powerful round. This change came with a cost. The clip capacity dropped from 10 rounds to 8. Engineers spent years testing and refining the hardware. On January 9, 1936, the military officially adopted it as the United States rifle, caliber .30 M1. This was a historical milestone. For the first time, a major global power made a semi-automatic rifle its primary infantry weapon. A debate still exists regarding the name. The designer's name is pronounced Garand, rhyming with errand. Despite this, many veterans and collectors call it the Garand. We will use the correct pronunciation. Records show John Garand himself preferred it that way. What made this weapon a revolution? It started with the feeding system. Senior officers feared detachable magazines. They believed soldiers would drop them or lose them in the heat of battle. There was also a mechanical concern. They worried an open magazine would invite mud and grit into the action, causing the weapon to seize. Garand's solution was the en-bloc clip. It was a simple U-shaped piece of stamped steel. It held 8 cartridges in a vertical stack. The process was mechanical and fast. The soldier locked the bolt to the rear, pushed the clip down into the top of the receiver, and pressed until it clicked. The shooter then pulled the bolt back slightly and released it. The heavy spring snapped the bolt forward, chambering the first round. With every pull of the trigger, the rifle cycled itself. After the 8th shot, the empty steel clip was thrown upward and out of the rifle. The sound was unmistakable. A sharp, metallic ping echoed as the clip hit the ground. The bolt locked open automatically. This served as a visual and audible signal. The rifle was empty. It was time to reload. The M1 was not a light weapon. Empty, it weighed 9.5 pounds. Once a soldier added a leather sling, a long bayonet, and a full clip of ammunition, the weight climbed to 11 pounds. In the field, every ounce mattered. Soldiers complained about the burden during long marches through the mud. The footage from training camps shows the reality. Recruits struggle with the weight during their first drills. For many, it was their first time holding the M1. It would soon become their most important tool for survival. 9.5 pounds. That was the weight of the M1 Garand. For a soldier on a long march, the rifle felt like a lead bar. Even before the first shots of World War II, the United States Army recognized the problem. The weapon was too heavy and too long for specialized troops. Vehicle crews, artillery teams, and radio operators struggled to carry it in tight spaces. This logistical headache led directly to the creation of the lighter M1 carbine. But the extra weight served a purpose. Why was the burden worth it? The answer was raw firepower. A trained infantryman could fire 40 to 50 accurate shots every 60 seconds. He could hit targets at a distance of 300 yards with high precision. In contrast, a soldier with a standard bolt-action rifle could only manage 10 to 15 shots in the same time frame. The math was simple. One American soldier produced 3 times the volume of fire as his enemy. The M1 Garand entered its first real trial during the Japanese invasion of the Philippines. This was the birth of a legend. The footage from the era shows soldiers firing from mud-filled trenches and dense jungle thickets. The rifle did not fail. Japanese prisoners provided the first clues to the weapon's impact. During interrogations, captured soldiers asked a specific question. They wanted to know how the United States could afford to give every single man a machine gun. This was the reality on the ground. The constant rhythm of semi-automatic fire was so dense that the Japanese believed they were facing automatic weapons. They did not realize they were fighting individual riflemen. The reports reached the War Department in Washington. The data was consistent. The Garand operated without mechanical defects in the worst possible combat conditions. Dust and dirt did not cause stoppages. Soldiers fired the weapon from foxholes for 7 days straight without cleaning the internal components. The rifle kept cycling. At first glance, it was just a piece of wood and steel. But in reality, it changed the nature of infantry tactics. Japanese maneuvers that had been successful for years suddenly collapsed. Their charges were met with a wall of lead that didn't stop for a bolt to be cycled. Every American became a high-volume fire point. But what happened when the Japanese finally captured these rifles? Their reaction changed their own approach to the war. Before analyzing their tactical shifts, other technical details of the Garand must be examined. The story was only beginning. December 1941. The Philippines. American soldiers had crates of .30-06 ammunition, but they lacked one critical component, the 8-round metal clips. Without these clips, the M1 Garand was useless as a semi-automatic weapon. Each rifleman carried 160 rounds of ammunition in his gear. There were not enough clips to hold them. Soldiers were forced to take 5-round stripper clips meant for the old Springfield rifles and strip the cartridges out. They reloaded the Garand clips 1 round at a time by hand. This happened in foxholes and behind trees while Japanese snipers fired at them. This logistical failure turned a high-tech rifle into a liability. It made a desperate defense even harder. But once the supply line stabilized, the M1 functioned as intended. The results were immediate. The rifle was superior, but it was not perfect. It had mechanical dangers. The most famous was Garand thumb. This occurred when a soldier loaded the rifle incorrectly. The heavy steel bolt would snap forward with massive force. If a thumb remained in the way, the bolt crushed the bone and tore the skin. It did not happen often in the heat of a firefight. However, it happened constantly during basic training. Soldiers learned the correct loading technique quickly. A single painful lesson was usually enough. Then, there was the issue of topping off the magazine. Once a soldier fired 3 or 4 shots, he could not easily add more rounds. If an engagement paused and the soldier took cover, he wanted a full clip before moving forward. The M1 made this impossible to track. It was difficult to see how many rounds remained inside the receiver. The soldier faced 2 bad choices. He could manually eject the clip and lose the remaining bullets in the dirt, or he could fire the remaining rounds into the air to empty the rifle. This wasted precious ammunition and revealed his exact position to the enemy. There were no other options. Sophisticated techniques existed for adding single rounds to a partially empty clip. These required 2 hands and several seconds of focus. In a combat zone where seconds meant life or death, these methods were impractical. The rifle was a masterpiece of engineering, but it demanded total mastery from the man holding it. Under fire, there was no room for error. The metallic ping of the M1 Garand. This sound triggered one of the most persistent myths of the Second World War. The story goes that Japanese soldiers waited for that specific ring of the ejecting clip. They knew the American was out of ammunition. They would then charge with bayonets. Was it true? In reality, it was almost impossible. Combat is loud. The roar of heavy machine guns, the blast of mortar shells, and the shouting of men filled the air. These noises drowned out a small piece of steel hitting the dirt. Veterans reported that the ping was barely audible beyond 5 feet. But the Pacific was different. Jungle warfare happened at close quarters. In the dense brush of Guadalcanal or Peleliu, enemies were separated by feet, not yards. One veteran described the danger. An enemy soldier hidden in the grass hears the clip eject. He lunges forward with a fixed bayonet before the Marine can reload. It was a rare but lethal scenario. The Marines adapted quickly. They learned to work in pairs. One man fired while the other reloaded. One rifle was always hot. Some soldiers even tried to weaponize the sound. They threw empty clips onto rocks to mimic the reload. They waited for the enemy to stand up. There is no evidence this happened often, but the tactic existed. The Marine Corps leadership originally hated the M1 Garand. They feared the semi-automatic fire. They believed it would lead to a waste of ammunition. They wanted to maintain the discipline of the bolt-action M1903 Springfield. The battlefield changed their minds. Marines saw the fire superiority of the Army. They wanted that power. It became an obsession. Marines began stealing or bartering for Garands. They snuck into Army camps at night. Some simply swapped their Springfields for unattended M1 rifles and walked away. The M1 offered more than just speed. It carried the M7 grenade launcher. In the mountains, this was a game changer. Marines used rifle grenades to arc explosives over ridges. They cleared entrenched Japanese defenders from caves and holes that direct fire could not reach. Now, look at the Japanese perspective. To understand why the Garand was a nightmare, we must examine their equipment. At the start of the conflict, the Imperial Japanese Army relied on older technology. Their primary weapon was the Arisaka Type 38. It was a bolt-action rifle designed in 1905. It was long, heavy, and slow. The Japanese soldier had to manually cycle the bolt for every shot. The American fired 8 rounds as fast as he could pull the trigger. This was a massive gap in firepower. On the front lines, the Japanese infantry found themselves outclassed in every skirmish. The technological divide was absolute. This imbalance defined the brutal infantry battles across the islands. 1905. This was the year the Japanese military adopted the Type 38 Arisaka. It was chambered in 6.5 by 50 millimeter. At 50 inches long, it was a massive weapon. It ranked as one of the longest infantry rifles used in the entire Second World War. The rifle was heavy, but the ammunition was light. The small round produced almost no recoil. This allowed inexperienced soldiers to maintain accuracy without flinching. The Type 38 featured a 5-round internal magazine. Soldiers loaded it using metal stripper clips. A standard rifleman could fire 10 to 15 aimed shots every 60 seconds. In high-intensity combat, a frantic soldier could push that number to 30. But the limits of the weapon were becoming clear. The 1930s changed everything. During the invasion of China, Japanese commanders analyzed ballistic reports. The 6.5 millimeter round was failing. It lacked the punch of the 7.7 millimeter ammunition used in their own Type 92 heavy machine guns. Even worse, the Chinese nationalists were firing 7.92 Mauser cartridges. The enemy had more range, they had more penetration, they had more stopping power. Heavier bullets allowed for specialized loads. This meant incendiary rounds to start fires. It meant armor-piercing rounds to punch through steel. It meant tracer rounds to guide fire at night. The old Arisaka could not compete. 1939. The military introduced the Type 99 Arisaka. It was chambered in 7.7 by 58 millimeter. The design was shorter and more compact than its predecessor. It was easier to swing in thick brush. The new cartridge delivered 18% more muzzle energy upon impact. It was a lethal upgrade. The Type 99 featured high-end engineering. It was the first military rifle in history to use a chrome-lined bore. This prevented rust. In the humid, corrosive jungles of the Pacific, this feature saved the weapon from rot. The rifle included a folding wire monopod. This was intended to stabilize the weapon for prone shooting. But the most unusual feature was the rear sight. It had anti-aircraft ladder sights with fold-out wings. These were designed to help a lone rifleman lead a moving plane. Was it effective? No. In reality, the feature was almost entirely impractical, but it revealed a specific fear. The Japanese military was obsessed with Allied air superiority long before the first bombs fell. The Type 99 became the new standard. It was a modern solution for a brutal war, but even a chrome-lined barrel could not change the outcome. The war moved too fast for bolt-action rifles. 7.7 millimeter versus 6.5 millimeter. This was the logistical nightmare Japan created for itself. The transition to a new caliber never finished. Both the Type 38 and the Type 99 rifles stayed in active service throughout the entire conflict. Supply units struggled to manage two completely incompatible types of ammunition. On the battlefield, the rifles looked almost identical from a distance. Confusion became a constant threat. Japan intended to replace the older weapon entirely. They failed. As the war dragged on, manufacturing quality collapsed. By 1944 and 1945, the factories were desperate. They used lower-grade steel. They stopped using chrome lining for the barrels. The finishes were rough and the welding was crude. The footage from the era shows the truth. You could see Japan losing the war just by looking at the rifles on the assembly line. But the gap between American and Japanese infantry went deeper than hardware. What was the core of the Japanese military mind? It was a concept called Seishin Kyoiku. This translates to spiritual education. It was a modern interpretation of the old Bushido warrior code. The core idea was simple. Superior willpower and mental toughness could overcome any material disadvantage. Numbers and steel did not matter if the spirit was strong. Japanese commanders learned this lesson years earlier. 1904, the Russo-Japanese War. Japanese forces defeated a larger, better-equipped Russian army. They used aggressive tactics and raw fighting spirit. This victory became the foundation of their doctrine. It was baked into every manual and every drill. But this philosophy led to a dangerous conclusion. Command believed the ultimate goal of infantry combat was not firepower. It was the bayonet charge. Their entire training system focused on this single moment. Bayonet drills were intensive. They were designed to erase fear and maximize aggression. Soldiers were taught to close the distance at any cost. The equipment reflected this obsession. This is why the Type 38 rifle was so long. The rifle itself measured 50 inches. When a soldier attached the 16-inch Type 30 bayonet, the weapon became a spear. It was designed for a war that no longer existed. Events accelerated. The Americans relied on semi-automatic fire. The Japanese relied on cold steel. The result was a slaughter. 350 millimeters. That was the length of the Type 30 bayonet. Fixed to an Arisaka rifle, it gave the Japanese soldier a reach advantage of nearly 5 feet. The entire imperial system was optimized for this one moment, closing the distance and finishing the fight with cold steel. In the 1930s, this worked. During the invasion of China, Japanese units faced opponents armed with slow bolt-action rifles. A determined bayonet charge could cross the gap before the defenders could reload. The math was simple. You took casualties on the move, but you broke the line. But against Americans, the math failed. Why did the charges stop working? It came down to a single word: volume. U.S. infantry carried the M1 Garand, the Browning automatic rifle, and heavy machine guns. The camera shows the result: human waves meeting a wall of lead. American fire didn't just slow the attacks, it shredded them. In the Pacific, the tactics that conquered China turned into mass suicide. Japanese squad organization was the next flaw. It was built around one weapon, the light machine gun. In this system, the riflemen were secondary. They didn't exist to kill. They existed to carry extra ammunition, provide security, and step in when the machine gunner was shot. All the killing power lived in a single point. If the machine gun jammed or the crew died, the squad was neutralized. American doctrine used a different blueprint. A standard 12-man squad included a leader, 10 riflemen with semi-automatic Garands, and 1 bar gunner. Firepower was decentralized. Every man was a high-volume shooter. There was no single point of failure. If the bar stopped firing, 10 Garands kept the pressure on. The squad remained lethal until the last man fell. At first glance, a disciplined army. But in reality, an outgunned force. To survive, the Japanese turned to the dark. They focused on night infiltration and small group raids. They used harassing fire and psychological stress to bypass the American rifles. But this wasn't a winning strategy. It was a workaround. It was a way to cope with a technological gap they could not bridge. The Japanese high command saw the mounting bodies. They knew the system was broken. By late 1943, the situation reached a breaking point. Events accelerated. A shift was coming. 1944. The Imperial Japanese Navy launched a desperate project. They needed a semi-automatic rifle for the Rikusentai. These were the elite naval infantry and paratroopers. The plan was simple: copy the American M1 Garand. How did they get the blueprints? They didn't need them. In 1942, Japanese forces occupied Manila. Inside the warehouses, they found thousands of M1 rifles. These weapons were left behind after the surrender at Patton. Soldiers packed the captured Garands into crates. They shipped them across the ocean to the Yokosuka Naval Base. 10 rifles were selected for the first experiment. Engineers dismantled them. They modified the chambers to fire the standard 7.7mm Arisaka round. Initial tests showed promise. The Navy gave the green light for full reverse engineering. The project moved to the Washino Kikai Company. This wasn't just a workshop, it was a factory intended for mass production. The weapon received an official name, the Type 4. But the transition from American design to Japanese reality was a disaster. Technical problems appeared on day one. At first, they tried a direct conversion. They kept the Garand's internal parts and only changed the barrel. The results were useless. The Japanese 7.7mm round had different dimensions than the American 30-06. The 8-round en-bloc clips jammed constantly. The rounds wouldn't seat. The springs failed. The engineers made a radical change. They ripped out the clip system entirely. They replaced it with a fixed 10-round internal magazine. Soldiers had to load the rifle using 2 5-round stripper clips. It worked for loading, but the weapon still wouldn't fire reliably. Why did the Type 4 fail? The answer was physics. The Japanese cartridge produced significantly less recoil than the American round. The gas system didn't receive enough pressure. The bolt moved back, but it stopped halfway. This is called short stroking. The camera would show the result. A spent casing caught in the action. The bolt would slam forward before the shell cleared the port, or it would fail to pick up the next round from the magazine. The rifle became a manual bolt-action weapon by accident. Testing logs painted a grim picture. Parts snapped under the strain. Jams occurred every few shots. Feeding failures became the norm. One engineer after another tried to recalibrate the gas port. They adjusted springs, they polished the internals. Nothing worked. By the time they realized the design was flawed, it was too late. The factory floor remained silent. Mass production never began. Thus ended the Japanese Garand. 125 rifles. That was the final count of the Type 4 production run. While factory workers manufactured parts for 200 units, the assembly line stopped short. The reason? The Japanese military command changed its priorities. Orders arrived at the facility to cease small arms production immediately. The machines were reconfigured to build aircraft engines for the failing air defense. Then came the B-29 bombers. American air raids devastated the industrial zones, shattering the supply chains and leveling factory floors. Japan surrendered in August 1945. The Type 4 project died with the empire. Not a single rifle ever reached the front lines. Not a single shot was fired in combat. Why did the American M1 Garand succeed where the Type 4 failed? The answer was industrial might and proven design. The Garand did not retire after World War II. It remained the primary service rifle for American troops throughout the Korean War. It didn't just arm Americans. The weapon equipped the majority of United Nations infantry divisions during the 3-year conflict. By the mid-50s, the design showed its age. The wooden stock and 8-round clip were becoming relics of a past era. In 1957, the Pentagon made it official. The M14 replaced the Garand as the standard infantry weapon. At first glance, a brand new weapon, but in reality, a modernized Garand. The M14 utilized the 7.62 NATO cartridge. John Garand himself worked on the design. He contributed to the rifle's development until his retirement in 1953. He saw his legacy evolve into a sleeker, magazine-fed platform. But there was no mistake. The M14 was a failure. It held the record for the shortest service life of any standard American infantry rifle. The era of the full-power cartridge was over. High recoil, heavy ammunition could no longer compete. Smaller, lighter intermediate rounds were the future. These new calibers would define infantry warfare for the next 50 years. The M14 era ended before it truly began.